one thing I do want to focus on is that last, like, 15 slides.
Yeah.
75 to 96, I think that's hard.
Yeah.
I think
same.
especially for your, like, it's hard. So first, before I go into that, I need you guys know what redox is?
Isn't it like releasing, or is it taking?
It's transferring electrons. So when you talk about redox, you're talking about an oxidation reduction reaction. So what does that mean? It just means you're transferring. I don't know if I spelled that right. It's all right, okay? You're transferring electrons between two atoms. That's what's happening. It's not like I'm giving it up. No. You're just sharing. You're transferring over, back and forth type beat. The thing with redox reaction is that it's usually going to be some sort of reactants, right? That lead to some sort of product, right? You have reactants, you have your products, whatever, right?
Mm-hmm.
That's where the transfer of electrons is happening between your reactants and your products. That's a very general definition of redox. It's also written inside Dr. Fondufe's slides. So none of the definitions I'm here, like I'm not making any of them up there, straight up there. So now, what I'm gonna do is, unfortunately, if I had a PowerPoint, I would have had the image up here. So bear with me, I'm gonna draw it real quickly so you guys can see what's a reducing agent, what's an oxidizing agent, right? Because
Yeah.
those terms,
They're confusing.
they're confusing,
Yeah.
right? And the thing is that they are confusing too. So give me 1 second, I'm gonna draw it for you guys. And I mean, if you have any questions, just ask me. I'm all for it, Okay. Yeah. Okay, so this is compound A, okay? This is compound A as well. Just wait. I have compound B, okay? I have compound B as well. What's happening here is that compound A has some electrons stuck to it. Okay? Compound A has some electrons stuck to it. When A and B react, okay, what's going to happen here is we get that redox reaction. Something gets oxidized, something gets reduced. What do you think oxidized means? What do you think reduced means in terms of electrons? Just guess. It doesn't matter.
Reduced means like more electrons are being lost.
Oxidized is like, well.
Think of it in terms of negative and positive numbers. Just think of it in numbers. Electrons are negative, right?
Mm-hmm.
If something gets oxidized, it's like going from negative to positive, right?
Mm-hmm.
If something goes from negative to positive, it means that electrons are being taken away, right? Because the only way to get positive is to lose negative numbers. So think of it as electrons. Does that kind of make sense? If you're not, just tell me. I don't mind telling you about it. You good? Do you kind of get what I'm saying?
Yeah.
Watch. When A and B react, what's going to happen here is A is going to give its electrons to B. Okay? That's what's happening. A gets electrons from B. Now, you might be wondering, well, what the heck is that, right? What those are, it's just what happens. That's just the products. Okay? This is the reactants, these are the products. I'm not done yet, okay? I feel like redox can be hard to teach at times.
Yeah.
I'm going to try to make it in layman terms so that it's easier to understand. When your electrons are when A and B are reacting with each other, you have the electrons on A. Electrons on A are going to give it to B. So if I ask you, A has electrons in the reactants part, right? A doesn't have electrons anymore when it's a product. So the products, that's the reactants, right? So, is this oxidized or reduced? Did A get oxidized or did it get reduced?
Oxidized?
Oxidized. Got oxidized.
Because it turned it into a positive, because it doesn't have the negative?
Yeah.
Okay.
Yeah. When something gets reduced, you're making it more negative. You're adding electrons onto it. So if I ask you, B has no electrons right now, right? But after it reacts with A, it does get electrons. So that would mean it's what? If you're getting electrons, you're becoming what?
Reduce.
Reduce, right? Do you see where I went with that? Do you understand where I went? If you're losing electrons, you are oxidized. If you are gaining electrons, you are reduced. Yeah. Oh, dang, that's not good. Okay. Gaining electrons. You see what I did? Make sense?
Mm-hmm.
Okay. Now you know what got oxidized, you know what got reduced, right?
Mm-hmm.
Now there's a thing called oxidizing agent versus a reducing agent. Think of it like this. An agent helps something become that thing. It just helps it. It's an agent, okay?
Mm-hmm.
It isn't that thing. That's
It's the one-
so
it's the one
arbitrary.
causing it.
Yeah, exactly. It's the one causing it. Okay?
Oh, yeah.
So if A gets oxidized, okay, and it gave the electrons to B, okay, it allowed for B to get reduced, right? A allowed B to get reduced because it gave its electrons there. And an agent causes that. We would call this a reducing agent. Does that make sense?
Yeah.
Do you want me to say it again? It's okay.
Yeah, one more time.
Okay. A gets oxidized. Oxidized means you lose electrons. Electrons got lost, and they're gonna react to B, and it gives it to B, right? A lost electrons, gave it to B. We know that if it loses electrons, it got oxidized. But when it gives its electrons, it allows for B to get reduced. Am I making sense? It's so.
Yeah,
Does it
so
make sense?
A is the what?
A is the reducing agent because it
Oh.
allowed for this thing to be reduced. How
Okay.
does it get electrons? Well, it gets it from A. A is a reducing agent.
I
because it-
thought it would be the oxidizing agent because it's losing.
yeah,
That's the confusing part.
that's the confusing part, right? I would.
But
So
it's-
but if it gives it away, it's not oxidized, right?
If it if it's losing electrons, it's
Mhm.
not called an oxidizing agent. It did get oxidized, but it's called a reducing agent because it gave its electrons to B. When we talk about A, we're saying that we're giving the electrons away. That's what it's saying. So who are you giving it to? Well, we're giving it to B. It's called a reducing agent because you gave it to B. When you say oxidized, it just says it loses electrons. It doesn't tell you who. So you say it's oxidized, right?
Mhm.
That's how I'm thinking. It makes sense?
Yeah, it's like
It makes sense.
it's like the agent is the one causing the other one to be like
The-
whatever's happening. So if
Okay.
the other one's being reduced, whoever like causing it to be reduced is the reducing agent. So
Okay.
A is making
That makes sense.
B reduced, so A is the agent that made it reduced.
Exactly.
Okay.
That's redox. In redox, it's not one thing gets oxidized. It's not that only one thing gets reduced. Both of these have to happen in any redox reaction. Redox literally means oxidation reduction. You can't just have oxidation. Because then where did you give the electrons? Who'd you give it to, right?
Yeah.
So something else got reduced. Make sense?
Mhm.
Okay, cool. So I know that this might be like really redundant. Maybe you've taken Gen Chem 1 or something and you already know this, but I just go through it regardless. We're good?
Can you give an example, like another one, so and then we can like
Mm-hmm.
tell you which one is the oxidized?
Yes, I'll do it. The thing is though is that hard. If I give you an example, I think that would really confuse you. Trust me.
Okay.
Yeah, because it's chemical. It's like I would have to balance it out and stuff, and that's hard. So sticking to basics.
Okay.
That
Mhm.
there's a mnemonic. If you can't remember this, I have a mnemonic for you. Okay. Let's see. Yeah, it's called Leo. Okay. Gur. It's called Leo Gur. Okay. Leo Gur is like Leo the lion Gurs. What this thing is saying is that when you lose electrons, you are becoming oxidized. Okay? That's what it means, Leo Gur. When you are gaining electrons, I'm just going to do electrons like that again, you are becoming reduced. Right? So, if I go back to this example right here, Gur means gaining electrons, you're reduced. Leo means you're losing electrons, you're oxidized. So right here, you lost electrons, right? Le. A to A. It had electrons, doesn't have it anymore. Lost electrons, it's oxidized. LeO. Get it?
Mhm.
If I have B gets electrons, right? Because it didn't have it before in the reactants, I get GER. G-E-R. GER. Gaining electrons. Reduced. Does that make sense?
I think there's like a more common one, oil rig.
Or oil rig. Yeah, oil rig's
so
another
it's
one.
like
Yeah.
oxidation is loss of electrons, so like oil oxidation is loss.
Yeah.
Yeah, and then rig is reduction is gain.
Yeah.
Yeah.
That's it.
Yeah, with that being said,
Mhm.
does this example assume that the, whatever A was, it has a -2 charge? Or was it already like stated?
Oh, I see what you're saying.
Yeah.
Yeah, you'd assume it had a -2 charge already on it. Yeah, yeah, okay. Let's just go ahead with acids and bases, okay? Let's just start with that. So, acids, and then you have bases, right? What makes an acid an acid? Like, if I were to ask you, if I gave you a molecule, how would you know that's an acid?
If the pH level is below 5,
Yeah, low pH. Right, so we'll say lower than 7. Okay. What's another thing that you know about acids? They usually donate hydrogens, right? They donate hydrogens. Okay? The next thing that you should probably know about acids is that if you look on your paper and you're like, oh no, I don't know if this is an acid or if it's a base or something like that. HF, HCl, H2, SO4. Ready? HClO 4. What do you find in common with all of these acids? H, right? If you don't know if something is an acid, the first thing that you can look at is if it has an H.
how come?
How come? Well, typically H's are very acidic. That's what it means. H's are very acidic. So if I can find an H like this, HF, HCl, even HI, right? Hydroiodic acid, something like that, right? Hydrochloric acid, hydrofluoric acid, sulfuric acid. All of these are acids because of this H right here. That's how you can tell if something's an acid or not. Now, the other thing with acids is that you should know that they come in 2 forms. They're either strong, okay, or they're weak. I can briefly talk over this, but what do you think when I say strong acid? What do you think that means?
Something that burns through.
Okay, yeah, I can see. Strong acid is something that's pretty dangerous, yeah, that's true.
Corrosive for some maybe?
Yeah, that's definitely another property of it. What else do you think? I'm gonna ask for more of a chemical type thing.
Has a lot of like bases that it can donate.
Yeah. So what we're saying here is that between strong and weak, and I'm gonna still talk about it, I'm gonna write it out so you can see it. Strong versus weak is our ability to ionize, our ability to dissociate, okay? When we talk about ionization, when we talk about dissociation, they're both relatively the same. Dissociation falls underneath ionization, okay? But really, we're saying here something is strong. If this is a compound, if this is my strong acid, and I put it in water, you know what's gonna happen to this thing? It's gonna break up. It's gonna completely separate. That's what happens with a strong acid. Completely separates when you put it in water, okay? If I have something weak though, and I put it in water, it's usually just gonna still look like this. It doesn't ionize. It does not break apart, okay? That's a weak acid. Weak acids, they're not that like dangerous. Acetic acid, vinegar, you can drink vinegar if you wanted to, right? It's not dangerous. I mean, it doesn't dissociate. Versus if somebody drank sulfuric acid, they would burn through, right? Like that's heavy stuff, okay? That's the thing about acids. And I can show you guys a mnemonic later so that you can remember the strongest acids. In that mnemonic, these are strong acids here except for HF. HF is not a strong acid, and I can't explain why really, but it's because it's just weak really. But I'll give you a mnemonic that tells you all the strong acids, and then anything that isn't on that list, you know it's a weak acid. Easy, okay?
Okay.
When we talk about bases, I mean, if this is a low pH, then what do you think this one is?
Hi.
Exactly, right? So high pH. Now this one's a little bit interesting. No, let's go this way. Okay. If acids donate H's, what do you think bases do?
Eight.
Yeah, they accept hydrogens. Now, I'm gonna say one thing. Acids come in many different forms. And when I say forms, I mean definitions. You can have a Bronsted-Lowry acid, you can have a Lewis acid, Arrhenius acid. They all basically mean the same thing. They're just focusing on different elements. When I say elements, I literally, not the actual periodic table, I mean like elements of what an acid is. I can explain that later. You don't really need to know it, just the general acids. Now, if I'm gonna ask you, how do you identify a base? How do you think you identify a base? Think. Like, if you don't know, it's all right. I'll show you. What are you noticing right now between these two?
Oh, the H's are like at the end.
OH.
So like, oh,
OH.
OH.
Yeah, OH. So with acids, you really focus on this idea right here of an H+. You call it a proton, right? You call that hydrogen ion, right? With bases, the way to identify is if you have this hydroxide. That hydroxide is right here, right here. And I can tell you on an exam, you would definitely be able to understand. If I showed up to you and I said, is HCl an acid or a base versus NaOH? It's pretty easy, right? You see the OH right here, that's a base. HCl right here, there's an H sitting there, I know it's an acid, correct? Pretty simple, right? Okay, now, weak bases are a little bit harder to identify. I'm not gonna really go through that because that's out of the scope of your class. But you do also have strong base, and you also have versus a weak base. What do you think that means? It's the exact same thing as this. A strong base and a weak base are very similar with their definitions. The only thing is that we're talking about bases. This one talks about acids, okay? It's the same thing. If something is strong, it's gonna completely dissociate. It's gonna completely ionize. If something is weak, a weak base I get, it might just sit around in water, it might not do anything. Does that kind of make sense, right? It's the same definitions. You're just talking about, is it an acid or is it a base? So now, I don't think I have any questions on it, do I? Nah, right? Okay, cool. All right, so the next thing I'm gonna talk about real quickly is that strong acid, strong basis type thing. Ionization is in your PowerPoint, and I got some questions and emails about it last night from a couple students. So I'm gonna go ahead and just explain to you ionization versus dissociation.
CIA.
Okay, dissociation, right? Okay, when you talk about ionization versus dissociation, okay, they're both very similar. I don't think you need to know the really nitty-gritty details of it. I'm just gonna give you a very basic overview. Ooh. One student got really confused and was like, I don't know the difference between these two. There is a difference. It's not very subtle, okay? Ionization, when we talk about this, we're saying some sort of neutral thing. When you put it in something, if you put it in a solvent, so if you take a solute, right? You guys know what solutes and solvents are, right? Okay, cool. If you take a solute and you put it in a solvent, what's gonna happen here is you're gonna get charged particles. They're gonna break up and you're gonna get charged particles. When you talk about dissociation, this is a little bit interesting. You already have charged particles. You already have charged particles. But you know what's happening to it? It's just gonna split up. So it's like the charged particle is together, but then it's just gonna split up to even more charged particles. I'll show you in a second. Typically, ionization has to do with covalent bonds, okay? And you'll see exactly why. Covalent bonds, okay? And dissociation usually has to do with ionic bonds. Y'all know what a covalent bond is and the ionic bond? You don't? It's okay. I don't know.
I forgot what a
Okay.
covalent bond is.
You're good. A covalent bond is usually a non-metal plus another non-metal. A non-metal plus a non-metal bind together and they form a covalent bond. They usually share electrons. That's a covalent bond, okay? When you talk about an ionic bond, we're saying it's some sort of metal with another non-metal. And by the way, if y'all are like writing a lot, don't worry, I will upload this because my focus here is that you understand what I'm talking about. It's
Okay.
I would hate for you guys to not understand because I'm going too fast. So it's there too, I promise, okay? Make sure absorb. So ionic bond is usually between a metal and a non-metal. Pretty straightforward, right? Now these ones, they transfer electrons. But what you should also know about an ionic bond, electrostatic attraction. That's how you identify an ionic bond. So we'll say electrostatic attraction. That's a ionic bond, okay? So now let me give you an example. Because now you're like, okay, Sophie, you said this is a neutral and then it's gonna split up to charged particles, and then you told me that, well, now these are together and then they just split up into charged particles. What does that mean, right? I'm gonna show you. Let's start here though. If you have salt in water, it doesn't ionize, it dissociates. I'll show you why. You guys know what salt is, right? NaCl. Na plus Cl minus. It's an ionic bond. You know that, right? Because it's a metal and a non-metal. Salt typically has that crystal lattice structure, right? It's that square thing, all of it, right? It's like the Na is right here, so I'll put positive for Na, minus Cl, positive, minus, plus. It's attracted to each other. Electrostatic attraction because you have positive and negative together, right?
Yeah.
Now, when you put this in water though, so let's put this in a solvent, we put it in H2O. You know what happens? It's gonna dissociate. I mean, think about it. You put salt in water and you stir it. Are you gonna see salt anymore?
No.
No.
Not the
It's gonna,
particles. Yeah.
exactly. It's gonna dissociate because you already have that positive negative. It's just gonna split up to positive and negatives. So you'll have NaC, Na, Cl minus, Na, Cl minus. They're just gonna be floating in this water. That's dissociation. You already had those charged particles. When you talk about ionization, okay, it's a little bit different. You're good, don't worry. It's a little bit different because if you have two H2O, don't worry about this, okay? I'll show you why. Okay. Do you notice something? Do you notice anything just about this equation? This is neutral. There is no charge on it. Neutral. All of a sudden, I guess they mix together, okay? Water and water. That's really weird, but it is what it is. You mix it together, okay? Neutral. All of a sudden, it's splitting up into these charged particles. Now you have the hydronium ion, and you have the hydroxide ion. Do you see how it went from neutral to charged? It split up. It was neutral. There was zero charge on this thing. Neutral. This one was already charged. It just went in water and it split up. That's the difference between ionization and dissociation. Make sense? Cool. Okie dokie. So now you know acids, bases, right? Okay, I'm gonna do blood buffer system. You guys know what a blood buffer system is?
Yeah.
No? I know what blood is too, right? Okay, so the thing is that with buffer systems, you gotta have a good understanding of pH because that's what a buffer system relies on. It relies on pH. So when you talk about pH, well, what do you think that is, right? It's literally acids and bases.
Yeah.
If something is over 7, pH of 7, we call that basic. If something is below 7, we call that acidic, right? With pH though, every system has a pH. Our living system is blood, right? I'm sorry. Blood has a specific pH that it needs to revolve around. If your blood is not at the right pH, we'll say 7.4, right? Jeez, sorry guys, this thing's going off. If it's not at that pH, you know what happens? something's going wrong with you, that's for sure, okay? Like, either you're dying or you're about to die. Like, that's a fact, okay? Bad stuff are happening to you. You need to have a buffer system to make sure that if your pH does go too high, if your blood becomes too basic, okay, you need to bring that back down. That's a buffer. The buffer is the mediator. It's like, oh yeah, you went a little bit too high, I'm gonna bring your blood back normal.
Mm-hmm.
Oh, your blood went a little bit too low, I'm gonna bring your blood back up.
Basically help like maintaining.
Exactly. Homeostasis, right?
Okay.
Every living thing has homeostasis. You have to have a balance in your body, okay? So with that being said, I am gonna write one thing though, because you gotta get this far, okay? I'm gonna ask you a series of questions. You just answer for me. If you don't know it, who cares? You know, we're all here to learn anyways.
Mm-hmm.
Acidic. If your acidity is increasing, what happens to your pH?
It
Drops.
lowers.
Yeah, the pH lowers. If your pH is lowering, what's happening to the hydrogen ions? What's happening to the protons? Is it-
Not there.
Are they increasing or are they decreasing? Are you having more protons in your body? Remember, H pluses are very acidic. They're very acidic. H pluses are acidic. So if my body or something is acidic, has a low pH, what do you think is happening to the H plus? Increasing or decreasing?
Increasing.
Increasing. Close. I'll show you. Increasing. Give you an example. If you have, let's say you have a lemon. That's actually not a good example because I don't know how to show you that part. H plus, if something dissociates, okay? Let's say actually ionizes, okay? HCl, right? That's neutral right now. I mean, it is acidic, but I'm going to show you why it's neutral because then it goes into H plus Cl minus, right? Right? H plus Cl minus. You know why they call this acidic? Because when you put this in water, okay, if I put HCl into water, it's gonna ionize. You're gonna get these molecules, right? You're gonna get these ions, H pluses and Cl. If I have a lot of H plus, right? If I'm putting a lot of HCl in water, it's gonna dissociate into H plus and Cl minus. The more HCl you put, the more H ions you're getting. The more H ions you're getting, the more acidic you're becoming. Because that's an acid. The only way to tell it's an acid is because of those H plus. Does that make sense?
Yeah.
Makes sense now why it's not decreasing? Yeah, it's increasing. Always increases when something's acidic. Man, if something's basic, you better tell me you know this part. It's just the opposite of all of this, right? Something's basic.
Mm-hmm.
Let's do it. Your basicity is increasing, right? Well, what's happened to your pH?
Drop.
You're funny. It increases, right? So let me ask you a question. If something is basic, what's happening to the H plus ions?
Decreasing.
Yeah, right? H plus is decreasing. Okay? I'm just gonna throw something out real quickly. If your H plus is decreasing, what ion do you think is gonna increase? If you know that this usually is OH minus, and you know that this is usually H plus, right? You have lots of H pluses if something's acidic. And basic just means you have a lot of OH minus, right? I mean, OH minus is what it is. Well, that's what it is. OH minus is increasing because H is decreasing, right? That's how you can tell. Okay? This is an indicator that your acidity is increasing, right? Acidity increase because more H. This is an indicator that your basicity is increasing, more OH minus, which basically means no more hydrogens. No more hydrogens, there is no acidity. So what do you call it? I call it basic. Make sense?
Yeah.
Okay, now we're gonna talk about buffer system. Any questions?
No.
Okay, let's go. Okay, buffer system? I told you. Explain again. What do you think a buffer system is?
Maintaining a pH level.
Yeah, maintaining a pH level, buffering system. The biggest buffering system, and this 100% on your exam. I mean, if it's a slide on there, it's on your exam. It's called the blood buffer. And I'm going to give you guys hopefully it's a good example. Hopefully you understand it. You don't need to memorize this equation,
Mm-hmm.
but on those practice questions that I have for later, it's relatively, like, you should probably know it, okay? So, I'm just going to write it real quick. your blood buffer system. I know this kind of looks like a bunch of ubajuga. When I first saw it, I was like, yo, I do not know what this is, right? I'm gonna explain it to you, and it's actually an amazing thing. It's really, really crazy, okay? I'm gonna start labeling these real quickly. Acid, call this carbonate. I need you to pay attention to this, and I need you to pay attention to this. Okay? Get another marker. Why I'm telling you to pay attention is because of the example I'm going to give to you so that you can understand this. Okay?
Mm-hmm.
Have you ever heard of Le Chatelier's principle? You've taken Gen Chem 1? Okay, I'm going to explain to you real quickly what Le Chatelier's principle means. I'm going to write it right over here. Le Chatelier is this dude, okay? He's this guy that said that if you have too much stress on one side of a system, so let's say I have too much, A to B, okay? Let's say I have too much stress on A. I have a lot of A, let's say it's 10, okay? Remember, your body wants to be at equilibrium, so if there's too much 10, it's gonna push to the side with B to even it out. So it'll go to this side, okay? It'll push to that side. There's too much stress, we'll put star means stress. So I'm gonna push to this side to make it equal, and maybe I'll have 5 and 5 now, right? That's kind of like Le Chatelier. It's trying to find a good bound. Now, if there's too much stress on side B, what do you think side B is gonna do? It's gonna push to this side. It's gonna push this side, right? If there's too much on this side, with too much stress, we'll push this way. Le Chatelier is very important. You're gonna see it if you're taking Gen Chem, like that's a fact, you're gonna see it. Now I'm gonna explain how it works here, because it has to do with stress. Remember I told you, if your body's under stress and the pH is increasing in your blood, that's not good, right? So it has to de-stress the system. That's what Le Chatelier says. If A is too big, if A is causing my blood to have an increase in the pH, it's gonna wanna move to the other side, right? That's how this works. I'm gonna give an example. Let's give a good example, okay? Let's say you're an EMT, okay? And you're a first responder, you're seeing somebody is on the street, they are not breathing, okay? If they're not breathing, you call that, hypoventilation. It just means that they're not ventilating. You don't even know that, but it's good, it's fun.
Mm-hmm.
They're hypoventilating, they're not breathing. If they're not breathing, do you think they're taking in oxygen? No, there's no oxygen being taken. Instead, what's happening in your blood is you're having an increase in carbon dioxide, right? No oxygen coming in you, you're having an increase in carbon dioxide. That's not good. That's where we see right here, the CO2 is increasing in this system in our blood. Okay, CO2 is increasing. There's too much CO2 in your blood, you're not getting any oxygen in. Now, what did I tell you before? Le Chatelier says that there's too much in your system. Carbon dioxide is increasing, okay? That's not good. Le Chatelier says, let's push to the right. So you're gonna push to the right, okay? To carbonic acid, okay? That's the first thing. I mean, it goes to carbonic acid. Carbonic acid just kind of sits there. It's like, okay, you made a lot of me now. Now this one's gonna increase, right? Because if CO2 is turning into carbonic acid, there's gonna be a lot of that, right? So then it's gonna do another push to the right, right? At the end, you're gonna push all the way to this side. Now, can I ask you a question? CO2 increases, right? Too much of it is gonna shift to the right. Now focus on this section here. Now we're gonna look at this section. If CO2 increases, what do you think is happening to your hydrogens if you're pushing to the right? You're gonna make more of it.
Yeah.
You're gonna increase your your hydrogen ions, okay? A lot of CO2, it doesn't like it on this side. It's like, oh my God, I don't want too much CO2. I'm sorry, they're just people who are just annoying right now. I'm gonna turn it off. If it happens again, sorry. Okay, too much CO2 on this side, right? It's gonna be like, no, I don't want too much CO2. I'm gonna push to the right all the way. Now it's making a lot of hydrogens. You think your blood likes a lot of hydrogens? No, because what does that mean if you have too many hydrogens? Acidic or basic?
Yeah, basic. Wait.
Acidic. Yeah, right?
Okay.
Now your blood is becoming acidic. So, that dude who isn't breathing right now, okay? He's getting a lot of carbon dioxide in his blood, all right? Blood's like, no, I can't have this anymore. So it starts shifting to the right the whole time. And now, your blood is getting acidic. Your blood is now getting acidic. That's not good. That's not good, okay? It's called acidosis. When your blood becomes acidic, that should not be happening. So, now we came to the point where there's a lot of hydrogens. This is where we focus now. What did I say about a buffer system? It's trying to maintain equilibrium, right? Yeah, that's exactly right. It's gonna now shift. I know this is kind of crazy, okay? So now we look at this. This is the person right now, they are dying, okay? I'm sorry to say this, it's pretty morbid, honestly. Yeah, blood is acidic, acidosis. And then we get into the hospital, and we're like, okay, we need to help this guy. We need to bring his pH to the right level. His blood is too acidic, okay? They'll do some sort of mechanism here. I don't know what the mechanism here is, but they're gonna try to restore the blood pH level. In order to do that, you need to shift back to the right, or to the left. Your left, yeah. You have to shift back this way, okay? Does that make sense? Perfect, that makes sense, that's great. So, some people have anxiety attacks, panic attacks, and when that happens, you hyperventilate. You breathe very, very fast. That doesn't mean to say like panic attacks only cause that. No, if I'm running a mile and I've never ran a mile, I would also be hyperventilating a lot, right? So if you're hyperventilating, that means you're having how much oxygen come into you? It's a lot, right? I'm constantly taking in oxygen, CO2. You're taking so much oxygen in, right?
You're also breathing a lot of CO2 out.
Yeah, exactly. You're breathing a lot of CO2 out. It's not staying inside of you. Like, yeah, exactly, right? So, now we have a problem. CO2, too low. It's not good, right? I'm gonna use blue instead. Your CO2 is dropping, okay? And while this is happening, because CO2 is dropping, your body is like, okay, I mean, the CO2 is dropping. That's not good. So your body does this mechanism where it's like, okay, I'm gonna start trying to make more CO2. So, bear with me. These two are gonna combine, okay? Because if something's too low, you wanna make more of it, right? You wanna make more of it. Well, if I have these already in my blood, carbonate, H+, they're gonna combine together to push back to carbonic acid. They're gonna try, because they're trying to make CO2. So you need to start here to get to here. We need to make more CO2 because CO2 is low. So carbonate and H+ in my blood are gonna come together. They're gonna make carbonic acid. Then carbonic acid is gonna split up and make the CO2. So I'm generating CO2 now. That's great, right? That's awesome. Okay, well that's actually not good, okay? You're pushing fully to this side. Let me ask you a question. If you are pushing fully to this side, okay? The whole objective here is CO2 is low, I need to make more CO2, right? That's what your body is saying, you need to make more CO2. The way to make more CO2 is to combine the H in this. H means that it's acidic, right? If I have a lot of H's in my blood, it's acidic. But if H is combining with carbonate, you think you're having H's in your blood anymore? No, you're not. They're combining. There is no more free hydrogens. So your blood is not becoming acidic anymore because you're combining these two. There's no more free-floating hydrogens. They come together, make carbonic acid, and then CO2. There is no more hydrogens anymore. There is none. They've combined it, they combined fully to come here. If your hydrogen ion concentration is decreasing, it's going low now too. I mean, if this is decreasing to go there, what do you think is happening to your blood? Is it acid or basic? It's basic. Your blood is now becoming basic. This is all happening during my mile. I literally couldn't run a mile. This is what's happening right now. My blood is becoming basic because of this whole reaction. So, God forbid something happens to me and I'm on the ground. This is happening. My blood is basic. You call it alcoholysis. Alkalolysis, I can't pronounce that very well. It just means your blood's basic. Not good. So I go to the, God forbid, emergency room. They're gonna do some sort of mechanism to get my pH back to normal. Which way do you think they're gonna push my pH? Which way are they gonna fix my blood buffer system? Yeah, they're gonna go back this way, because there's too much, it's too basic. So, you're gonna shift this way. This is what's gonna help me, shifting to the right. It's too basic right now. You have no hydrogen ions. You've combined fully. The blood needs some hydrogen ions, right? That's why you push it back to the right. Okay, you get it, right? Cheat sheet, real quickly. If my pH is dropping, my blood's getting acidic. So we'll say blood is acidic, okay? Which equals your pH is dropping. If your pH is dropping, that means that it's shifting to the right, right?
Yeah.
That's what's happening. So how do you fix that? How do you fix it? What does the buffer do? What the buffer is going to do is, if your pH is dropping, okay, it means it's shifting to the right. What the blood buffer system is going to counteract that, it's going to shift to the left. It's going to shift this way, right? Your pH drops, okay? Too much is made on that side. So we're going to shift back this way. That's what the buffer system does. That's how it counteracts it. This is a good thing. We're going to put a smiley face, right? Getting you back to normal. If your blood is basic, it means your pH is what? Let's say if your blood is becoming basic and it's increasing, that means that you have too much on this side, right? So you're going to shift to the right.
Right.
Exactly. Because there's not enough of this. You need to make more hydrogen. So we're going to shift. Sorry, let's go that way. Sorry. Shift to the right. That's happy. That's what the blood buffer system does. It's going to shift it back that way. You understand it now, right?
Yeah.
Okay, we're good. I'm going to call it.
Makes sense. But we don't have to know the formula, right? But like it's gonna be like an example.
I think you do. Because I've seen questions. Dr. Fondufe said that I can go over my exam questions with you. Of course, I'm not going to post it anywhere. But
Yeah.
previous exams, I feel like you would need to know this. Yeah, if it's on the PowerPoint, I would know it.
Okay.
Yeah.
Anything on the PowerPoint. is very good.
Really, anything on the PowerPoint, you got to know it. Yeah.
Question, what is something that could mess up this buffering system?
Well, something that could. Well, anything really, if you think about it, because it all has to do with breathing. Somebody dying, somebody is alive. God forbid. Oh my
Even
God.
like dehydration. Because do you know where you get your hydrogen ion? From water. It's H plus and OOH minus. That's where you get your H plus from.
Yeah.
This is why you really need to drink water. Your blood pH ranges between 7.35 and 7.45.
Yeah.
If it goes anywhere outside of that, that causes problems, which is why drinking water is so important.
Could
Yeah.
you ever be overhydrated?
Yeah.
Yes.
You could be overhydrated. And what do you think that means? It's not good. That's it. That's what it means. It's not good.
There's been multiple stories about people that have died during like football practice and stuff like that because they're overhydrated.
Yeah. Wow.
That's crazy.
Yeah. So you guys get it, right? This makes more sense now, I feel like. So when you go into the review her lecture, this will make way more sense. Because I remember a lot of people are like, I don't know what the buffer system is. And now you know the buffer system. So that's good. Okay, now, do I need to go over anything else? I know you have your questions on atomic weight and mass.
Yeah,
I can go
yeah.
over those with you
Okay.
later.
Sure.
Okay, is there anything else though on the slides that you didn't understand? Alright, I feel like most of it's a good chunk.
This was like the one thing that I was just very confused.
That's that. I'm gonna stop recording.